Hello and welcome. So in previous few sessions, we learned about what exactly data sets and data frames are in Spark, how they are different from each other, how they are different from RDDs. In the last hands-on session, we also saw how to run actual SQL commands on top of data sets or data frames. So in this session, we will see how we can not only run SQL commands, but we can run SQL-like functions on data sets, which makes the job even easier. So let's look at this example. So in this example, we are creating a Spark context just like we did it last time. And this time we have a case class called score record. It contains 3 columns: roll number, subject, and score. And data looks something like this. You have a roll number, you have a subject, and you have score. And I mean, I'm just doing a head here, but you have multiple rows with multiple subjects and different scores for different students. So let's see how we can process this data using SQL-like functions in Spark SQL. So once you have created your Spark session, what we are doing here is we are creating a scores data set by reading the file that we just saw, and we are providing as score record, which basically combines this schema with that data set, and it returns you a scores data set. Here we are just printing that schema, and these are the functions that I was talking about. So just like SQL provides you basic functions, right? Like select, filter, group by. So we are going to look at these few functions which are most commonly used in SQL, world, and we'll see how we can apply these functions on data sets without actually writing direct SQL commands. So if you look at this command, what I'm doing here is I'm on this data set, I'm calling this function called select, and I am giving a column called subject. So basically what I'm doing is this command is similar to doing a SQL query, which says select subject from scores TS. And then you're doing just show, which will give you list of all the subjects in the scores data set. Similarly, in this command, I am applying the filter function where what I'm saying is scores TS dot filter. And I am saying that score column should be greater than 90. There are 2 ways you can do it. You can say underscore dot score, because data sets are compile time compatible with schemas. So you can write this as well, or you can even write, score in double quotes. So let me just show you how you can do that. So what you can do is you can also write it like this. Okay. So both are valid statements. All right. Let me remove this one. And in the third statement, what we are doing is we are first applying select on subject and score. So we are selecting these 2 columns, subject and score. And then we are applying group by function where I am grouping by the subject and summing all the scores by providing the sum function. Okay, so basically what it will return us is sum of all the scores for a given subject corresponding to that subject, right? Let's try to run this and we'll see what we get. All right. So if you look at this one, this is just printing the schema. That was our first statement about print schema. Then we had a select where we are saying select subject from the scores TS. It is basically giving you list of all the subjects. It's just showing 20 rows by default here. You can actually pass parameters to show command to, see more columns, more rows, but that's fine for now. Our third statement was to filter on all the scores, on all the records where score is greater than 90. So it is giving you a list of all the records where your score is greater than 90. And then we were doing group by on subject, and we were summing the scores. So this is telling you for science, this is the total number of scores, total, sum of all the scores for math, for English, for Hindi, right? Let's try to do, instead of sum, let's try to calculate average. And that is very simple. Instead of sum, you just need to use the function average, AVG, average. Okay. If you remember, in one of our previous sessions, we did the same exercise of computing average score per subject using RDDs. If you don't, if you want to recap that, I suggest you go to that video. I think it was in lesson 4 or 5 somewhere. You can see that video, how we computed the same thing using RDDs. It required a lot more steps, but using Spark SQL or using datasets, you can actually achieve that in single statement. If you really see, this statement is like this SQL query. Select subject sum of score from, let's say, scores DS, if that's the table name, group by subject. So this SQL command is what we are implementing through SQL functions provided by datasets. Okay, so let's see how the average gets computed. So let's compile this. And let's run this. So this time, instead of the sum of all the scores corresponding to a subject, what we'll get is, we'll get the average score per subject. Right? Here it is. What we are getting here is, for science, this is the average score. So it has already summed all the scores and then divided by the count of students. All right. Make sense? Okay, so if you see, what Spark has done is, it has bridged the gap between the relational databases world and your distributed computing. So what you have got with Spark SQL is that you can run your SQL-like queries or SQL-like functions on an entire cluster of machines, which makes it much more efficient than a simple relational database, right? That's it for this session. I'll see you in the next session.